Today we're going to be looking at how to solve radical equations. And with that comes equations that involve rational exponents, since we know we can convert between having rational exponents and radicals in our equations. So what is a radical equation? It is an equation that has a variable, in a radicand, or has a variable with a rational exponent. So here are some examples of the first two are radical equations, because see, this is 3 plus the square root of x equals 10. So we have a variable under the radicand. And here we have a variable raised to a rational exponent. The third example here would not qualify as a radical equation. Although it is an equation and it contains a radical, there isn't a variable under that radical, so that doesn't qualify. So how do we solve these? Let's look at some examples. So the first step is always to isolate your expression with the radical. So in this case we have 5x plus 1 under the radical. So I want to get rid of this minus 6 and move it to the other side. So we'll say isolate the radical first. Okay, so I'm going to go ahead and add 6 to both sides. So that gets rid of the minus 6. So I'm left with the square root of 5x plus 1 equals 6. Now, how do I undo a square root? Well, the inverse of a square root, the inverse operation, is squaring something. So what I'm going to do, here's my original equation. I'm going to square both sides of my equation. And now I have the square root of something being squared. Those two operations undo each other. So I'm just left with the 5x plus 1 equals 6 squared is 36. Now I'm closer to getting x by itself, which is what I'm trying to do. So I'm going to then subtract 1 from both sides. 5x equals 35. And now we just have a simple one-step equation. So this would be x equals 7 after I divide both sides by 5. And I've solved. Let's try another one. Okay, it looks like my radical is not isolated yet. I have this negative 10 over here. So let's add 10 first so that I can isolate my radical. Equals negative 5 plus 10 is 5. And now it kind of looks just like this step did over on the left side. So I'm going to go ahead and square both sides. It's a square root, so squaring that square root undoes the square root. It's an inverse operation. So I get 2x plus 1 equals 5 squared is 25. And now I just have a simple two-step equation. Subtract 1 from both sides and divide by 2. And I'm done. All right. Next, we're going to talk about this other property that involves rational exponents. So it says you can solve equations of the form x to the m over n power equals k by raising each side of the equation to the power n over m, which is the reciprocal of m over n, reciprocal of this. So those, remember to isolate the quantity raised to the power first. Okay, so the basic idea of this is the fact that if let's say, we'll just kind of have a little sidebar over here. If I have, let's say, 7/3, if I take that fraction and multiply it by its reciprocal, 3/7, when I multiply two reciprocals together, I get just 1. So, see, the 3's would cancel out, the 7's would cancel out. I'm just left with 1. Okay, so this is the idea behind this property here. So what I'm going to do is I have 2 times the quantity x plus 3 raised to the 3/2 power equals 54. I want to isolate this quantity in parentheses first that's being raised to this fraction. So it's being multiplied by 2. I need to divide by 2 to isolate it. So I now have x plus 3 to the 3/2 equals 54 divided by 2. That is 27. Okay, now how do I get rid of this fractional exponent? What I'm going to do is I'm going to take both sides and raise it to the reciprocal of this fraction. So it's 3/2 right now. I'm going to raise both sides to the 2/3 power. Now, when I do my power to a power rule, I have 3/2 times 2/3. Just like we talked about over here, when I multiply two things that are reciprocals, I get 1. So these exponents essentially cancel out and just give me 1. So this is like x plus 3 now to the first power. And now I have 27 to the 2/3. Thinking back to section 5.7, when I have a rational exponent, I can rewrite this in radical form, which is power over root. So if this would be the cube root of 27 to the second power, power over root. And now I also have the property that tells me I'm allowed to move that squared to the outside, because I might not know, what 27 squared is off the top of my head and then be able to take the cube root of that. But I do know the cube root of 27 is 3. So now I have 3 squared, because the cube root of 27 is 3. So I now have x plus 3 equals 9. Subtract 3, x equals 6. And I'm all set there. Okay, next I have a similar type of problem here. Just getting some more practice. So I'm going to start by, I have a rational exponent. This expression here with the rational exponent is not isolated yet, so I need to get rid of the 3 that's multiplying it. So I'll have x plus 1 to the 3/5 power equals 24 divided by 3 is 8. Okay, now I'm going to try to get rid of this rational exponent by raising both sides to, it's the 3/5 power. I'm going to raise it to the 5/3 power. Now when I multiply two things that are reciprocals, those cancel each other out. I'm just left with x plus 1 on the left side. And that's going to give me, so let's switch this to radical form, because I don't know what 8 to the 5/3 power is. But I can figure out the cube root of 8 raised to the 5th power. So I switched from having a rational exponent to radical form. Now I know the cube root of 8 is 2. So now I'm raising 2 to the 5th power. 2 to the 5th power is 32. So I get x equals 30. Oops, somewhere along the line I accidentally switched this to a 2. I don't know how that happened. These should have been 1s. Let's change that. So then I now have x equals 31 once I subtract the 1. Sorry about that. Okay, done. Alright, flip your paper over. And we'll talk about another similar property here. It says that if x to the n power equals k, so if I have some number raised to a power and that equals another number, then I can raise both sides of my equation to the 1 over n power. If I'm trying to solve for x, n times 1 over n, those cancel out, they're reciprocals, so that allows me to solve for x here. So it's very similar to the property we just discussed. It's actually pretty much the same. So let's use it here on our volume formula for a sphere. And this is example 3. So the volume for a sphere is given by the formula V equals 4/3 pi r cubed. If the volume of a given sphere is 1600, what is the radius? Okay, so this is just the idea that I'm going to, 1600 is my volume, so I can plug that in for V. So, and I'm looking for my radius. So essentially I'm just solving this equation for r. Okay, so what do I do first? I'm trying to get r by itself. Let's start by getting rid of this 4/3. I know if I multiply 4/3 by 3/4, 4/3 times 3/4 is 1. So that's going to get rid of the 4/3 for me. Now when I do 3/4 times 1200, or sorry, times 1600, I get 1200. And that leaves me with pi r cubed on the right side, because 4/3 times 3/4 is just 1. Okay, I still don't have r by itself. So let's then divide both sides by pi to get rid of the pi. So I now have 1200 over pi equals r cubed. So now it's kind of, 1200 over pi is just a number. It's a decimal, but now it's kind of in the form of what we have up here. So what I'm trying to solve for is r, and it's now raised to the 3rd power. So if I raise both sides to the 1/3 or 1/3 power, I'll do that over here. So that gives me, let's see, 1200 over pi equals. So to get rid of this 3rd power, I'm going to raise it to the 1/3 power, because 3 times 1/3 is just 1. So that's going to leave me with r to the 1st power. And let me just clear out my calculator here. So this is something that you could get a decimal approximation for. So I'm going to go ahead and just type this part in my calculator, because I do want to get an approximation. So I'm going to put 1200 over, where is my pi button? Oh, here it is. Pi is right down here. Close your parentheses, because I want to raise that whole expression to the 1/3 power. So I'm going to use my little caret right here. And then when I type that exponent in, make sure you're going to put it in parentheses. So 1/3. Put your exponent in parentheses when it's a fraction. Hit enter, and it's going to give me my decimal approximation, which is about 7.26 if I round. And I've solved for r. Good to go. Okay, a couple more examples. Now we're going to talk about extraneous solutions. So sometimes the directions might say to solve and check. Actually, in your homework, it doesn't tell you to check. So this is an extra step that you're going to need to do for each problem, is to check. Always check. Okay, so just so you don't forget. Now, what does that mean? Well, let's first start by solving. So let's just solve this normally, and then we'll talk about what we need to do to check. So this looks like a normal radical equation. I'm going to subtract 3 from both sides to isolate my radical. So I get square root of 5x minus 1 equals x minus 3. And now we're going to square both sides.